So hi, hello everyone, welcome back to the our channel. If you are following this series, you might know that we have started the series of machine learning subject and the subject code BCS602. So far we have completed the module 1, module 2, module 3 and module 4 important question answers, model question paper, previous year question paper and numerical problems along with the solution from each module. So in this video, we are going to discussing about the module 5 based on the model question paper and previous year questions with the reference we are going to study. Okay. So in this module 5, we have two chapters. Uh, First chapter clustering algorithms and second one reinforcement learning. In the first chapter, the clustering algorithm introduction to the clustering approaches, proximity measures, hierarchical clustering algorithms, partitioning clustering algorithm, density based methods and grid based approaches. These are the contents are in the first chapter. In the second chapter, reinforcement learning, that is it has a overview of reinforcement learning, scope of reinforcement learning as a machine learning, components of reinforcement learning, Markov's decision process, then multi-arm banded problem and reinforcement problem type, model-based learning, model-free methods, then Q learning, SARS learning. These are all a part of a second chapter, and don't worry guys, here almost all theory is there, and almost most of the questions are appeared repeatedly, so there's a chance of appearing in upcoming exams as well. Don't go through the entire syllabus. Wherever the important topics and concepts are there, concepts are, you just have to cover those topics. That's it. So without wasting time, let's get start one by one. Okay, so the first question is analyze the grid based approach and mention the steps of a CLUE, that is a CLIQUE. So you need to define, explain about the grid based approach. It is a space based clustering technique. It works by the partitioning the data space into the cell and fitting data into these cells for clustering formulation. Okay, there are three key components in a grid based clustering, that those are all subspace clustering, dense cell, then monocity property. Then comes the algorithm, subspace clustering subspace. So here they have given like steps how the working procedure will be there. So for that you need to describe that. You just go through this description. Okay, so description, the content is there. Used for a high dimensional data, not all dimensional are necessary for every applications. And the examples are indices profiling is may be needed, but address is not. Okay, so for this is the example for the subspace clustering. Then again, only a subspace of a feature is required for a meaningful cluster. Okay, that part is there. And again here CLUE algorithm is there. Here two stages are there. So in the first stage you need to in the first stage there are three steps. The first step is a identify the dense cells. You need to identify the dense cells, then merge dense cells C and Cj if they share the same interval. So if they sharing the same interval, then you need to merge the both Ci and Cj. In the next, in the third step, generate a prior rule to form a k plus 1 then dimensional k plus 1 dimensional cell. Here checks whether the number of points in the generated cells crosses the threshold or not. You need to check, then repeat the above steps until now no new dense cells are found or no further generation of a dense cells is possible. Okay, and in this stage 2 you need to go to the again in the first step, merge dense cells into the clustering in each subspace using a maximal region. And again, a maximal region is a hyper rectangle that covers all the dense cells. Okay, so step 2, what we need to do here, maximal region attempts to cover all the dense cells to form the cluster. Okay, CLUE starts merging from a dimension 2 and continue up to the n dimensional. So this CLUE algorithm starts from stage 2 onwards, but before you need to do the some prior work. that is there in the clue algorithm one stage one. So before work executing that clue algorithm, you should have to do some prior work. That's the reason. But uh, it has a both, clue algorithm has a stage one and stage two. You need to write all, both stages. Okay, then moving on to the second question, apply k-means clustering algorithm for a given data with the initial value of a object 2 and 5 considered as a initial seed. It is a numerical problem. Again, if I start to explain orally, you might feel bored, but I will just highlights the overview how the procedure will work. So you must have to solve this problem, then only will understand and you are able to solve this numerical problem in your exam, if it is, if it will appear in your question paper. Okay, so the objects and x coordinates, y coordinates are there. uh, Here initially the objects, the 2 and 5, they have given objects 2 and 5, right? So you need to consider 2 and 5. Oh, it's gone, guys. Just refer the question paper, I think, because it is gone here. It is disappeared. That's okay, you just refer this question in the question paper. I extracted this question from the question paper itself. Okay, let wait for a minute. Okay, I have added a manually values 5, object 5, and x coordinator is a 12, the y coordinator is 4. So initially you need to find the cluster 1 and cluster 2 as per the given test cases, initial seeds 2 and 5. So you need to take this as a cluster 1 and cluster 2. So the cluster 1 is 4 comma 6, I have written here. Then the cluster 2 is 12 comma 4, 12 comma 4, and we need to take it as a centroid of a 4 comma 6 and a 12 comma 4. Now the centroids are these. Let's start a iteration. In the first iteration we need to find the distance from first object to the cluster centroid. Okay, so the distance of a first object 1 to the centroid, centroid 1. So yeah, this is a centroid 1, right? And this is a centroid 1 and this is a centroid 2. We need to find the object 1 with the centroid points 4 comma 6, that is the cluster 1. Okay, so I have written here sample object is 1, and with the with a cluster 1, that is a 2 comma 4. So here you need to do the again Euclidean formula, that is x2 minus root of x2 minus x1 whole square plus y2 minus y1 whole square, like that. So you need to here x2 is a it will become a x1 y1, and the value which are there here, it is a x2 y2. Here x2 is y, y2 is 6. So x2 minus x2 minus x2 minus x1, that is a 4 minus 2, then 6 minus 4 I have written here. You can also take it as a reverse. 2 yeah, x2 minus x1, I said x2 minus x1, right? So 2 minus 4 whole square plus 4 minus 6 whole square, you will get a root of 8. Similarly for a centroid 2, centroid 2, that is a 12 comma 4, you need to do that. Again 2 comma 12, 2 comma 2 minus 12 whole square plus 4 minus 4 whole square I have written here. Again we'll get a value 10, like that only. Distance from a 3 object 3, 2 we are 2 is the initial seed is there, so we are not taking that. Again object 3, like that you need to take the 3, then 4, 3 and 4. 5 is also not taking because it is a initial seed. With the centroid 1 and centroid 2, like that you need to solve. Guys, if I explain this orally, it might feel you bored. So try to solve this by yourself. If you are not getting, just comment below. I will do this problem solving separately with the manual solving, so that while solving step by step you will understand. By explaining as like a theory, it little bit complicate. So yeah, you just go through this. Okay, uh, then comment below if you are not getting. again iteration 1 is done, then like that only you need to do the iteration 2. Finally you will get a result. Okay, let's see the third module, third question. Determine characteristics, applications and challenges of a reinforcement learning. Here you need to mention the characteristics of reinforcement learning. The characteristics are four: sequential decision making. First one, uh, the path of sequential decision making is a path from start to goal is sequence of a in a sequence, like a single wrong move may result in a failure. uh, that is the thing. Okay, so second one is a delayed feedback, then third one is a interdependent action, and fourth one is a time related action. Okay, uh, and each characteristics have a two single line description. Just read. Okay, then let's see the challenges of reinforcement learning. Here reward design, absence of a model, partial observability of states, then states consuming operation complexity is there. Okay, then comes to the application of reinforcement learning. We can see in industrial automation, resource management, traffic light control, personalized recommendation system, advanced bidding, customized application, driverless cars, games with a deep learning, a deep mind application. These are all applications of reinforcement learning. Moving on to the next fourth question, find the Manhattan and Chebyshev distance if the objects are 0, 3 and 5, 8. It is a very simple numerical problem you can solve easily. Here you need to know about the Euclidean distance formula and you need to subtract. So let's take this one as a x1 and sorry, this one yeah, this one is x1 and x2, whatever, however you can take, but you need to subtract with the x with the x and y with the y. That's it. So the root of 0 minus 5 whole square plus 3 minus 8 whole square, you will get a root of 50. Then if you simplify this, you will get a 7.07. Then the Manhattan distance using this formula, it is also there. The mode of this minus this, here square root and the root is there, but in the Manhattan distance there is no square root. Okay, square and root both are, you just 0 minus 5 plus 3 minus 8, again you will get a 10. Then the Chebyshev distance using xi comma, again here formula is there. You just have to enter the values maximum of this distance, which one, Manhattan distance. Here the mode of 0 minus 5 and mode of 3 minus 5, you will get a max of 5 comma 5. Here both are same, so you will take anyone, maximum is 5 the answer. Then moving on to the fifth question, describe the component of reinforcement learning with a diagram. Here the diagram is there, it is an important one in this fifth module. This diagram you should have to practice in the sense it is a simple diagram. There is no need to draw even if you remember the components: environment, rewards, agents, states and action. 5 components. Okay, so let's see each one by one. The environment, the word well, where all actions are taken place, it defines the input and output rewards. Then agents, agents are an autonomous entity, human, robot or program that interacts with the environment by performing actions. Okay, this is a agent. Then state, the input to the reinforcement learning system represents the current situation or a condition of the environment. Okay, so the action, the output from the agent, the decision token based on the current state. Then rewards, numerical feedback receives the after performing. Okay, these are the components of this reinforcement learning. Then the next question, explain the mean shift clustering algorithm you need to explain. Here maximum 5 steps are there, you just go through this. Like first step, design a window, then place the window on a set of data point, then compute the mean for all the points that are comes under the window. Okay, then moving on to the move the center of the windows to the mean computed in a step 3. Thus, the window moves towards the dense region. The movement to the dense region is controlled by the mean shift vector. Here, the mean shift vector formula is given. Here, k and explained each terminology. Then the centroid is updated as a x is equal to x plus v1. In the final step, you need to repeat these steps 3 and 4. These steps 3 and 4 you need to repeat. Um, for a convergence, once convergence is achieved, no further points can be accommodation. This is all about the algorithm. You just go through this PDF and wherever the theory is there, read guys, and numerical problems solve from your side. So if you are able to solve, that's well and good. If you are, if you are getting confusion, then just comment below, so I will do the problem part as well. So from starting onwards, I will start wherever the problems you are getting confusion, I will start. Okay. So yeah, that's it all about all the series. We have completed this machine learning, all 5 modules, important questions, model question paper solutions, and numerical problems. uh, that's it all about machine learning subject. Thank you guys.